Okay, so let's start. Let me share my window. Okay, everyone can see this, right? Okay, so today we will solve gate question from gate 2023 questions. So today we will solve from calculus 2 questions. I have already recorded the video, so I just play them and you can ask the question if you have any doubt. Okay. Can you see the video which I have opened? Hello?
No, sir.
Can I see? Okay.
I think now it is some hexagonal structures are visible.
Okay. Right now?
Sound is audible. Only sound is audible.
Only sound is coming.
Mathematics Gate 2023 question from calculus. This is the
No,
question
fan
number.
ka no me.
Yes?
So it is what it is saying. Let f and
Not the video. You cannot see the.
No, sir.
Okay. So I've shared my screen, but what you can see right now?
Question number 11.
Yeah, that is the video I'm saying. Right? This is the question,
Yes,
so
sir.
we'll
Yes,
solve
yes,
this
yes.
one. Yeah, okay. Okay, so so we'll solve first the GATE 2023 question number 11 from calculus. If you have any doubt, you can ask. Okay, so let's start.
okay. So let's start. So today we will solve mathematics Gate 2023 question from calculus. This is the question number 11. So it is what it is saying. Let f and g, two functions from R2 to R. They are defined by f of xy is x square minus 3y2 xy square and gx x comma y is 4x to the power 4 minus 5x square y plus y square for all xy in R2. So consider these two statements. So P statement is saying that P has a saddle point at 0, 0 means at origin, and Q is saying that G has a saddle point at 0, 0. Then we have these four options. We have to check which one is correct. So option number A is both P and Q are true. Option number B is P is false but Q is true. Option number C is P is true but Q is false. Option number D is both P and Q are false. Okay, so let's solve this one. So these are the NPTEL reference. So before solving the question, we need few definition and results. So let's look at this. So first, let f is a function from some open subset of Rn to R, where omega is open set. We say that f has a local maximum at a point f in omega if fx less than equals to fa for all x in some neighborhood of a. Similar for minimum, so we say that f has a local minimum at a point a if fx greater than fa for all x in some neighborhood of a. Right. And local maximum and local minimum are referred to as local extrema. Moreover, if this inequality means fx less than equals to fa hold for all x in the domain, then we say that f has a global maximum. And if fx greater than equals to fa for all x in A, we say that f has a global minimum. Right. Now let's define. So this is we define this is called the gradient of f. Gradient of f at a. This is defined. This is by del f del x sum partial derivative of f. These are m partial derivative. This is vector. Okay. So now let's look at one more definition. So this a point a in omega, where the gradient of f is 0 is called the critical point of f. Right. Okay. Now, so this is the critical point. Now let's look at this. This is the definition. This is called the Hessian matrix of A. Hessian matrix, Hessian of A at the point A. So how this is defined? This is the all the partial second partial derivative. The first one a11 component is the del f by del x1, del 2f by del x1, like this. So in the diagonal, all the del f by means del 2f by del xi as there. In the off diagonal, the mixed partial derivatives are there. So this is called the Hessian of f at a. We also, so let's use the another definition. A critical point A is said to be non-degenerate if the corresponding determinant of the Hessian matrix is non-zero. Right. So critical point when there is a gradient of f is 0, and a non-degenerate critical point which is neither local extrema, means neither local minima or local maxima, we call it a saddle point. Okay. And so for this, when the point is non-degenerate, we have a means result. We have a theorem from where we can determine the point is local maxima, local minima, or saddle point. So this is a for n equals to 2. N equals to 2 we can easily check. So let's f is a function from omega, which is subset of R2, open subset of R2 to R. Let be C function because we need the partial derivative to exist for at least order 2. And let A be a point which is non-degenerate. So this is important. The point is non-degenerate. And let alpha is called del 2f by del x2, beta is del 2f by del y, del x del y, gamma is del 2f by del y2. Then if alpha gamma minus beta square is positive and alpha is positive, then f has a local minimum at A. What option 2 is saying, if alpha gamma minus beta square is positive and alpha is negative, then f has a local maximum at A. And number 3 is saying that if alpha gamma minus beta square is less than 0, then f has a saddle point at A. So what is basically saying that for n equals to 2, if you look at the corresponding Hessian matrix of f at A, so this is look like del 2f by del x2, this is del 2f by del x del y, because this is symmetry matrix, del 2f by del x del y and del 2f by del y2. So it is saying that if this Hessian matrix is positive definite, then f has a local minimum at A. If this is negative definite, then f has a local maximum at A. And if this matrix is indefinite, then f has a saddle point of f at A. Okay. So let's then solve the question number 11. So f is given x square minus 3 by 2 xy square.
So,
Yeah.
can we get these notes like?
Oh yeah. I will share this then. Yeah, means you can watch the video in NPTEL website also, and there is a one Excel sheet where you can find this video.
These previous videos.
Yeah.
So can you share the link maybe of that spreadsheet or something?
Okay.
Thank you, sir.
So what is okay. F xy is x square minus 3 by 2 xy square. So we have to check that 0 0 is a saddle point or not. So let's check at first find the partial derivative of f with respect to x. So what is del f del x? It will be 2x minus 3y2 y square, right? And what is del f del y? It will be minus 3xy, right? So let's find the gradient of f at the point 0 0. So it will be del f del x at the point 0 0 and del f del y at the point 0 0. So if you put it here, you will get both 0 0. So gradient of it at the point 0 0 is 0 vector, so which implies 0 0 is a critical point of A, right? So now we have to find the Hessian matrix to say that this critical point is non-degenerate or degenerate. So let's find the Hessian matrix. So for that we need the second partial derivative. So find del f del x2. So it will be 2, right? What will be del 2f by del y2? It will be minus 3x. And the mixed partial derivative, because these are C2 functions, they are same, del 2f del y2, del x del y, del 2f del y del x, both will be same, and it will be, so it will be minus 3y, right? So then what will be the Hessian matrix? H of it. So at the point, suppose first xy point at general point, it will be del 2f, so it will be del 2f by del x means 2, it will be minus 3y minus 3y minus 3x, right? So Hessian matrix at the point 0 0, it will be 2 0 0 0, right? So what will be the determinant? Determinant of h of at the point 0 0, it is 0, right? So as the determinant is 0, which implies 0 0 is degenerate critical point, right? Degenerate critical point. So as 0 0 is degenerate critical point, so we cannot use this theorem, right? Because this is applicable for non-degenerate critical point. So for degenerate critical point, we have to examine the function, means we have to go by definition. We have to examine the function in a neighborhood of 0 0, right? So let's look at this. So for non-degenerate critical point, so what is fxy? Remember, fxy is x square minus 3y2 xy square, right? So you have to analyze this function in a neighborhood minus 1 by 2 y to the power 4, which is strictly less than 0, strictly less than 0 if analyze this function in a neighborhood of 0 0. So let's write it like this. Take half x by 2 common, so then it will be 2x minus 3y square. So we have factored it out, and note that f of 0 0 at the point 0 0, the function takes the value 0. So now note that this has a 2 factor, right? One is x, one is 2x minus 3y square. So along the, you can see that along this parabola 2x equals to 3y square, this function is 0. So if you check, take this parabola on this, suppose x equals to, if you take y square, then what will happen? Then f of y square comma y square will be half y square, and if you put x equals to y square, you will get minus y square, right? So this is basically minus 1 by 2 y to the power 4, which is strictly less than 0, strictly less than 0 if y is not 0, right? So in a neighborhood of 0, along this curve x equals to y square, if y is very close to 0 0, this function is 0, less than 0, right? And you can easily check that if you take this curve on x equals to 2y square, then what will happen? Then f of 2y square comma y, so it will be half 2y square, this will be y square, right? So this is y to the power 4. So this is strictly positive if y is non-zero, right? So we see that if you take y as close to 0, so in a neighborhood of 0, this function takes both the value in a arbitrary close to 0 0, right? So this function changes is not uniform. It means as f0 0 is 0 0, but in a neighborhood it takes both values greater than 0 less than 0. So 0 0 is not a local maximum or minimum. So from here we can conclude that 0 0 is a saddle point of it. Saddle point of f, right? So for f we have done it. So now we have to do it for g similarly. So f has a saddle point at 0 0. So p is correct, right? Now let's check for g. So what is g? G is 4x to the power 4 minus 5x square y plus y square. So now g xy. So this is the similar. So let's do it. Minus 5x square y plus y square. Again we have to check the 0 0 is critical point or not. So let's find del g del x. So del g del x will be, if we differentiate with respect to x of g, we will get 16x cube minus 10xy. Del g del y, so you will get minus 5x square plus 2. And let's find the other partial derivative del g by del x2. So it will be 48x square minus 10y del 2g by del y2. It is 2 and del 2g by del x del y, which is same as del 2g by del y del x, which is minus 10x. So let's check what is gradient of g at the point 0 0. So del g del x at 0 0 and del g del y also 0 0, so it is 0 0, which implies 0 0 is critical point. Of g. Now we have to check it is non-degenerate or degenerate. So let's find HF Hessian matrix at 0 0. So what it will be? It will be del qgx by del x2 at the point 0 0. So it will be 0, and it will be minus a to 0 0 2. So we'll get this is the Hessian matrix at 0 0. Then what will be the determinant? So this is again 0, which implies, so 0 0 is degenerate critical point.
Sorry, here f will be g, that I forgot. So it will be 8g at 0 0.
So again we cannot use the theorem to conclude that 0 0 is a saddle point or not. So we have to again go by definition. So let's analyze the function g in a neighborhood of 0 0. So what is gxy? Gxy is 4x to the power 4 minus 5x square y plus y square. So let's factor it out. If you factor it out, you can see that this is looks like 4x square minus y into x square minus y, right? And again g of 0 0 is 0. So again, by looking at these two factors, we take these two curves. we first take y equals to 3x square. So what will happen along this curve? Then gx 3x square, it will be x square times minus 2x square. So it is minus 2x to the power 4, which is strictly less than 0 if x not equals to 0, right? And take the another curve when this will be positive. So take y equals to half x square. Then g of x half x square, what it will be? So if we check, it will be 7 by 4 x to the power 4. So which is positive if x not equals to 0. So again we see that at g of 0 0 is 0, and on a neighborhood, if you take x is non-zero and very close to 0, then this function changes value. So, along this curve with y equals to 3x square, it takes the value less than 0, and along y equals to half x square, it takes the value y equals to is greater than 0. So as it is changes sign, which says that 0 0 is a saddle point of G. So both the points are saddle point of f and g. So what we have got, that g has a saddle point at 0 0. So this is also correct. So which options are correct? Both p and q are true. So option A is correct, and all other options are false. Okay. So let's stop. Bye.
Okay, so any question from this question number 11? Anyone have any doubt?
No, sir.
Yes. Okay. Yeah. Y equals to 4x to the power should be checked. Oh, okay. How to choose this means card. Okay. Here you are saying how to choose this card, right? Why 3x square or 4x square? So in a neighborhood you have to check for saddle point that it changes sign, right? If in a neighborhood it is always greater than, because on 0 0 it takes the value 0. If in a neighborhood of 0 it always positive or negative, then it will be either minimum or maximum, right? So you have to show in a neighborhood of 0 0 the card means g of xy, this function takes both values, right? So for that, when this g of xy you can make it positive or negative. So if you choose this y equals to 3x square, then the first factor will be positive, but the second factor will be negative. So that's why I have chosen 3x square. You can choose any value between 1 and 4, right? It will work to make it.
Yes.
And for the other, when how to make it positive?
X is non-zero.
So to make it positive, I have chosen half x square, so that both factors become positive, right? So that's why you can choose anything 1 by 3 or less than 1. You can choose some scalars. Do you get it?
Okay.
Any other doubt? Okay, if not, then let's move to the next question. Okay, I will try to upload these notes in the Excel sheet where you have access in the. Okay, I try to upload the notes in the Excel sheet.
So generally, like
Yeah.
here we could factorize and then we found the points at which there is like a change in the sign,
Yes, yes, yes.
negative and positive.
Yeah, because
What if we are not able to factorize, or what if
then you
like
have
if
to.
questions like that?
Yeah, means then you have to try to means guess means which where this time suppose at that point it takes 0 or some value, so you have to check where this changes the sign. Means if it is uniformly same sign, then this is the maximum or minimum, right? So you have to find some way where this will change its sign. It's not necessarily that you have to factor it out always. You have to find some, it means test it over some point where it will positive or negative.
Okay, thank you, sir.
Okay, let's start then the next question.
Okay, so today we will solve mathematics Gate 2023 question number 11. It's question from calculus. So what it is saying, let f to r be a function which is defined by 2x square y by x square plus y square for xy not equals to 0 and 0 for xy equals to 0, 0. Then there are 4 options are given. What is option number? Option number A, the directional derivative of A at the origin in the direction of 1 by root 2 comma 1 by root 2 is 1 by root 2. Option B is the directional derivative of A at 0, 0 in the direction of 0 comma 1. So this is y-axis is 1. Option number C, the directional derivative of F at 0, 0 in the direction of 1, 0. So in the direction of x-axis is 0. And option number D is f is not differentiable at 0, 0. Okay. So this is NPTEL reference. Now, so before solving this, we need few definition results. Let's recall the definition of the differentiability. So let's f is a function from omega to Rm, where omega is open subset of Rm, and a is a point in omega. We say that f is differentiable at a. If there is
So
a
the video
transformation
is not audible.
Rm.
Yeah. Oh.
The sound of the video is not audible.
Okay. Okay.
So when you put it on mute, we cannot hear.
Okay. Okay. Yeah. Yeah. Right now, can you hear?
So let's f is a function from omega to
Yes, sir. Yes.
where
Okay.
omega is open subset of Rm and a is a point in omega. We say that f is differentiable at a if there is a linear transformation from Rn to Rm such that this will hold. Whether in the numerator it's taken the norm in the Rm norm and this is the Rn norm in the denominator. So if this will hold, we say that f is differentiable at a. Okay. Now the directional derivative of a next at the point A in the direction of a non-zero vector u is denoted by du of du suffix u f at the point A, which is defined by limit t tends to 0 f of a plus tu minus f of a by t whenever the limit exists. So this is called the directional derivative of a in the direction u at the point A. So this is the gradient of f. So this is the gradient at it. And next we need this theorem that it's saying that if f is which is a defined on a open subset of R and R is differentiable at a point A, then any directional derivative will exist, and the directional derivative can be computed by the in terms of this inner product taking gradient with the direction u. This theorem we will use to prove the last option. Okay, so let's start to solve the question. So first we have to find the directional derivative of f at the point 0, 0 in the direction of 1 by root 2 to 1 by root 2. Okay, let's start. So we have to find directional derivative d in the direction. So let me write first. Here u is 1 by root 2. So in this direction we have to find at the point. So this is denoted a at the point 0, 0. So you have to find del u f at a, means d 1 by root 2 comma 1 by root 2 f at the point 0, 0. So this is by definition limit t tends to 0 f of, so this is a plus tu minus fa by t, right? So a is here 0, 0 and t is the real number and u is the 1 by root 2, 1 by root 2. So if we put this in the function, what is the function here? Let me write f of xy. So this is 2x square y by x square plus y square if xy is not equals to 0, 0, and this is 0 if xy is 0, 0, right? So what will happen if we put this? Then we will get, you can see, you will get limit t tends to 0. So what you will get? 2, you will get t square by 2 into t by root 2 minus 0 by t. Oh sorry, not here, it will be by t square in the denominator, and this is minus 0 by t. So if you calculate, put this, all these things in the function, you will get this. So if you solve, so what will be this? Limit t tends to 0. This is basically tq by tq root 2. So it will cancel out. What we will get? 1 by root 2. So directional derivative of f at the point 0, 0 in the direction 1 by root 2, 1 by root 2 is 1 by root 2. So this is the option A. So option A is correct. Okay. So let's move to the option B. It is saying we have to find the directional derivative of f at the point 0, 0 in the direction 0, 1. So this is basically y-axis, right? So this is also called the partial derivative with respect to y. You can, if you think, you will get that this is same as saying that finding partial derivative in the direction of y. So let's find the direction derivative in the direction 0, 1. So this is option number A. What B? What we have to find? Directional derivative in the direction 0, 1. Right. So D of 0, 1 f at the point 0, 0. So this is by definition limit t tends to 0 f of again 0, 0 plus t of 0, 1 minus f of 0, 0 by t, right? So if you put this in the function, what you will get? Let me write it. So you will get, this is basically 0 minus 0 by t. So it will be 0. So the directional derivative of f at the point 0, 0 in the direction of 0, y is 0. So this is basically partial derivative. So this is del f by del y at the point 0, 0. So this is 0. So option number B, what it is saying? So this is, they are saying this is 1, so this is false. Okay, now let's check the option number 3. So we have to find the direction derivative of f at the point 0 0 in the direction 1 comma 0. It is 0. So this is same the question of option B. So let's check. So option C, we have to find d of in the direction 1 comma 0 of f at the point 0 0. So this is by definition limit t tends to 0 f of 0 comma 0 plus t 1 0 minus f of 0 0 by t. So again, if you calculate this, you can see that this we will get 0 minus 0 by t. So again, this is 0. So this direction derivative will get 0. So this is same as, you can see that this is del f by del x at the point 0 0. So this is 0. So see, it is saying the direction derivative of f at 0 0 in the direction 1 comma 0 is 0. So this is correct. Minus f of 0 0 is exist and it print. Option number 2, we have to find that f is saying that f is not differentiable at 0 0. So for that we will use that theorem that if a function is differentiable at a point A, then direction derivative in any direction is exist and it will can be computed by this. So we will use this theorem. So let's see. So this is D. So let's take this direction 1 comma 1. So we have to, so let's find directional derivative in the direction 1 comma 1 of f at 0 0. So what will be this? So this is by definition the limit t tends to 0 f of 0 comma 0 plus t of 1 comma 1 minus f of 0 0 by t. So if you put these values in the functions, what you will get? You will get 2t cube by 2t square minus 0 by t. So if you calculate this limit, what you will get? You will get 1. So directional derivative of f in the direction 1 comma 1 at the point 0 0 you will get 1. Right. So if f is differentiable, at 0 0, then by that theorem it should have directional derivative at the point 1 1 f 0 0. It should be given by inner product with gradient of f at the point 0 0 with the direction 1 comma 1, right? So this should be true. So let's compute the derivative. So this is the, here we use the theorem. So note, what is gradient of u f at 0 0? So this we know, this is del f by del x at the point 0 0 and del f by del y at the point 0 0. Note that we have computed these two in B and C. So del f by del y is 0, del f by del x at the point 0 is 0. So this is 0 comma 0. So now find the inner product. So then, so gradient of f at 0 0 with 1 comma 1. So what this will be? So this is inner product with 0 0 with 1 1. So this is basically 0, right? So what we got? that this inner product is 0, but we got this directional derivative of f at 0 0 in the direction is 1. So these two are not equal, right? As df d11 f at 0 0 is not equals to 0 0 inner product with 1 1. So which implies f is not differentiable at 0. F is not differentiable at 0, 0. Right. So what we got? Option number D is correct. So here A, C, D are correct, B is false. Okay. So question number 52 is done. Okay, let's stop. Bye.
Okay, any doubt from this question number 52? No question? No question. So you can find these videos in the website. NPTEL website, Gate2023 website. You can look at that. And I try to, I try to upload the notes also. And this video recording of today's recording, I will upload it in the YouTube in my channel. You can find it there. Any other doubt?
No, sir. Clear, sir.
Yeah. In the next session, we will discuss on linear algebra problem. So question number, so GATE in general question number 11, which is question number 11, it has only one answers are correct. So and 52, I think for after 36 or somewhere the multiple MCQ type of questions. So that's why in the question number 52, one or more options are correct. But in question number 11, so only one answers are correct. So you can find it in the means yearly questions, you can find it the details. So for something for 11 to something, only one answers are correct. After that multiple more answer can be correct. Okay, then stop for today. We'll meet in next week. Okay, I'm stop sharing.
Yes, sir.
Yeah.
So our Gate NPTEL website, there is no mathematics problem solving link, sir.
No, yeah, it is there, right? You can find the videos.
Gate Video Solutions only computer science and electronic engineering something there.
Yeah, or yeah, if because mathematics started this year only, so if you cannot find it, you have not find any email from the NPTEL. I think they will share some Excel sheet from there. You will, so there the YouTube video link will be there, or this solution link will be there. So from there you can watch it.
So can you give solution links, sir?
Okay, I will put it in my YouTube if you cannot find it there.
YouTube link.
But how do I share to you? So means it will be shared by NPTEL. I can't say.
So if you can just share your YouTube channel link in the comment box here, like chat box.
Okay. Yeah, I have shared it here, but I think in NPTEL you can find it there also, or if any Excel sheet shared by NPTEL, there you can also find it. I think after some times NPTEL will update the portal, Gate NPTEL portal. So from there you can easily check the videos.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah. Okay.